It's Friday night, the 6th of October. It's about 8 o'clock in the evening. Let's see, I'll look at the handset. Yeah, about 8 o'clock, a little bit earlier. What I'm going to do now is I've turned the scope on to NGC 7217. I'll give you some data on it. But what I want to do is step through a series of settings to show you at what point it begins to reveal itself. It means I'm going to have to fumble a finger around a little bit with the buttons on top of the imager unit. That's not where we want to go. So 4 was like a 2-inch telescope. 8 should be like a, 16 at 36 decibels will be a 6-inch. So here we are, 8 flood, which I think is a 4-inch scope. Yeah, because when we double it, you'll divide the 4 by 2 and add it to 4 to get 6. I think I'd have all this memorized, but I don't. I have to figure it out every time, and that's probably good for me. Now, we're looking at NGC 7217. I'm going to get some data on it. Basically, the idea is, early on I'm going to characterize how the galaxies look. Then later on, what I'm going to do is going to go to almost a maximum setting, and we're going to start viewing any galaxy that's 12th magnitude or brighter until I have to take up my Sky Quest for tonight. Anyway, the data on NGC 7217 is it's a galaxy in Pegasus, as you may well know, magnitude 10.1, 4 by 3.4 arc minutes, 47 million light years distant. Now, everything we're going to look at tonight is going to be at least magnitude 12.0, and they're all going to be in the middle third of the sky because we want to really get a sense of this. Now, I'm not going to step through all the settings. I just want to give you an idea. Now, if you multiply the 4 by 3.4, you get something like 15. And if you take the log 2.5 of 15, I think you get something like 3. So basically, the average surface brightness of this galaxy is around magnitude 13. And therefore, the only thing we would see at these settings at best would be the core. Okay, I do remember that shutter 16 flood and 36 decibels of gain, AGC max, is roughly a 6-inch scope. Now this galaxy should reveal itself on the screen to a 6-inch scope since its average surface brightness is within the faintest magnitude stars that could be seen by a 6-inch scope. And a lot of it depends on sky conditions. Now, I am not seeing it, but we should be in the sky dark now. I just don't know if there's any high thin clouds, but the day was very blue, bright, and lovely, so I don't suspect we have high thin clouds, unless, of course, the cooling off of the atmosphere, because it was rather warm today, is causing the humidity to rise. So there's our 6-inch setting. At 32 decibels of gain, we've basically doubled from 16 to 32. You divide 6 by 2 and you get 3. Add 3 to 6, you get a 9-inch scope setting. Now a 9-inch scope should reveal studies down to magnitude 0.8 magnitudes fainter than a 6, and a 6 should get down to magnitude 13.5 on a decent night of seeing. Now I'm not seeing the galaxy up there. So this is just something to keep in mind. This galaxy is well within the scope of an 8-inch telescope or 9-inch telescope using an eyepiece. Why don't we just go ahead and I'll bump it up again. 64 flood basically doubles the aperture of anything that's at 16 flood. So 16 flood was roughly equivalent to that of a 6-inch. We're at 64, 16 times 32, 4 times is 64. We should be getting a view through a 12-inch scope at this point. Now I am seeing the galaxy. I believe the core is quite visible. However, the core of a 10th magnitude face-on galaxy is any galaxy is the brightest part. This galaxy is pretty close to face-on, it's football shaped. The core should be about magnitude 0.8 fainter than the 10th magnitude. So this should be a 10.8 magnitude core. And I do believe it's turning up on the screen. So now we're at 12-inch settings. So I'm going to go to 128 flood. Now, if we doubled from 64 to 128, we're now operating at half of 12 plus 12, which is 6 plus 12 is 18-inch setting. Once again, I'm just not seeing it very well from my position on the screen, but when I shift over, I can see the core and extensions. I would expect it to look better than that, so I'm not sure exactly what's going on right at this point. Let's do one more doubling to 256 flood and see what she looks like. Well, by my estimation, we should now be getting a 2 times 12-inch view. Remember, 12 was 64. 64 multiplied 4 times is 256. That adds a magnitude and a half to your reach. Basically, a magnitude and a half added to the reach of any scope doubles the aperture. So now we were at 12. We should be at roughly the equivalent view of a 24-inch telescope, and we are getting a very nice view of the galaxy and extensions. So I have to inspect this in the morning because I did not get a very good view from my viewing angle, but I would have expected the galaxy to start showing the core basically through a 10 magnitude galaxy through a 4-inch settings. 6-inch and on up should start showing an expanding aura of nebulosity in the core region and any spiral arms. Now for our last leap, I have increased from 36 decibels to 44.8. And as you recall, we roughly estimated 36 decibels, 256 flood was 24. So you divide 24 in half, you get 12, you add it to 24, you get 36. This is the deepest reach the Rev2 real-time imager is capable of because it is maxed out in terms of the exposure time, maxed out in terms of how many overlays, which are 6, and maxed out in terms of sensitivity of the actual sensor system inside the camera. So let's give it a few more seconds and allow it to finalize its integration of 6 passes. Once again, we're looking at an NGC 7217 Galaxy and Pegasus, magnitude 10.1, probably with an average surface brightness of about 13. It's a spiral with a lowercase b. It's a mere 47 million light years distant, which basically means it's probably 90 to 100,000 light years in diameter. It's well up into the middle third of the sky at 31 degrees, almost a half. And it lies at right ascension 22 hours, 7 minutes. Okay, watch as the image after image of 7217 disappears from the screen. One thing that should happen is I've shifted the scope by about 20 degrees, and the next galaxy should appear somewhere within the aura of the former galaxy 7217. Keep in mind I have also left the values for imaging at the maximum setting, which is roughly equivalent to a 36-inch scope. So let's watch this as I get the data on NGC 7280. So you'll know what to look for. Should take about 40 seconds to a minute to fully integrate the image. NGC 7280 is a galaxy in Pegasus, magnitude 12.1. Now it's 2.1 by 1.5 arc minutes, a spiral with a bar, and it's of the lenticular class, 82 million light years distant. It's at plus 16 degrees. Now let me explain something about these football-shaped galaxies. First off, the core should be about magnitude 12.9, which puts it within the range of a 6-inch scope. After that, if it were an edge-on galaxy, we'd add 1.5 to each side of the galaxy, which would put it at about 13.6 for the brightness of the two extensions of the core that you would normally be able to see through a small scope. You wouldn't be able to see beyond the extensions in most scopes because those are so faint they contribute hardly any light to the brightness of a galaxy. Now, since this is not an edge-on galaxy, if it were an oblate galaxy, the extensions, oblate meaning a 2-to-1 ratio, this isn't a 2-to-1 ratio, it's about 2 to 1.5. If it were oblate, you would add about 1.5 magnitudes, you would add about 2.5 magnitudes to each extension. So the extensions would be about 14.5 on this galaxy as a general rule. Now it's a football-shaped galaxy. Now if it were a face-on galaxy, the entire extensions would be 4 magnitudes greater, so that would be magnitude 16.1. So somewhere between 14.5 and 16.1, about magnitude 15.2, is the brightness of the extensions of NGC 7280. Every galaxy is different, however, but it's good to have an idea of what you might expect to see in the scope and the eyepiece. Okay, watch as this galaxy takes form. It's NGC 7311. I'll get the data on it. Once again, we're operating at the highest sensitivity and longest exposure times. It'll take 40 seconds to a minute for the image to fully assemble, and I have to be very careful not to move around as it does so. NGC 7311 is a galaxy in Pegasus. It's at plus 5.5 degrees, magnitude 12.5. And this is why I selected it. It's in the 12th magnitude range. But it is a pure oblate, 1.6 by 0.8 arc minutes, which means the width is twice. The width multiplied by 2 gives you the height, or dividing the width by 2 gives you the length by 2 gives you the width, sorry. It's a spiral with a lowercase ab, 204 billion light years distant. Now, because it's oblate, you have to add about 2.5 magnitudes, 2 to 2.5 magnitudes. So the core is going to be what it is, 0.8 magnitudes fainter than 12.5, which is 13.3. And then the extensions, we're just going to add 2 to the 12.5 for an oblate, and maybe 2.2, but let's just call it 2 for right now, will be about 14.5 to 15th magnitude, well within the reach of the scope. So we should be seeing the extensions. But it's small, so there's a resolution image there too. So what we're looking at here should be something that looks kind of tilted, like a saucer, tilted, and we should be able to see both the core and the extensions of the galaxy bleeding off into space. And those extensions should each be about the same size as the core itself, as a rough rule of thumb. So NGC 7311. What we're looking for here is galaxy NGC 7315 in Pegasus. Like 7311, it's magnitude 12.5, but unlike it, it is a pure face-on, 1.6 by 1.6 arc minutes. Now, It's a spiral of the lenticular class O, which means there's not really any spiral arms. Basically, it looks like a disk of light. Now, what we're looking for here is, since it's a magnitude 12.5 galaxy, and it is fully face on, we have to add about 4.5 magnitudes to get a sense of how bright the whirling light is around that core, which puts it at about magnitude 17, which should be within reach of this scope. I think I see the galaxy right in the middle of the screen, so the go-to and tracking is very good this evening. This galaxy is at plus almost 35 degrees, and it's 22 hours and 35 minutes at this point. So there is our look at a magnitude 12.5 face-on galaxy. There's one other class we want to look at, and that's a pure edge-on, and I'll see if I can turn one of those up. Okay, watch as this one develops. It's not an edge-on. Calling up the data now. NGC 7323. This is actually a face-on galaxy, and the reason why I selected it is because it has a ring. So this is a magnitude 12.9, NGC 7323 Galaxy in Pegasus, 1.4 by 1.1 arc minutes. It's a spiral of lowercase b with a ring. Now, rings are typically about 4.5 magnitudes fainter than the galaxy itself, so anywhere between 4 and 4.5. So that puts this one at about magnitude 17, which should be within the reach of the scope. So look to see if there's an annularity outside the core, and because it is not a lenticular, that ring is literally formed because the outer spiral arms are moving at such a rate that it's trailing star material back behind it, is my estimation of how they come about. Now you might want to look up to confirm that. So there's our view of a ringed galaxy with a slight football shape to it, NGC 7323. Go ahead and watch as this one forms, and see if you can, if you've been following this series, you should be able to recognize it. Looks quite Saturnian, doesn't it? This, of course, is one of the most spectacular galaxies available to us this time of year. No, it's not Messier 31, 110, or 32, but it is NGC 7331, a galaxy in Pegasus, magnitude 9.5. Now, the intriguing thing about it is it spreads this light a long way. 10.2 by 4.2 arc minutes. Spiral with a bar, 46 million light years distant, and plus 34, almost a half degrees. Now, if you multiply 10.2 by 4.2, you get 40. And if you take the log of 2.5 of 40, you're probably going to get something like 3.5. So you add that to the 9.5. And this is a magnitude 14 average surface brightness galaxy. It's presenting like an oblate would be 10 by 5. This is 10 by 4, so it's a sub-oblate, not exactly a edge-on. But that does mean it has compacted a good deal more light into its extensions than you might expect. So in that case, it's between the 1.5 of an edge-on and the 2.5 or so of an oblate. So we're saying we're adding 2 magnitudes on. So those extensions are basically magnitude 11.5. But they are spread out over more space, which means basically more diffuse in brightness. The key to this next galaxy, which should form in the aura of 7331, nothing in particular about it, but it's fairly bright. Now I want to show you galaxies that are in the magnitude 11 range as well. So get some data on it. Now you can see why I can't operate at these settings. I could never get through 40 or 50 NGC studies in an evening if I had to wait a minute each. The camera battery would run out. I don't think it would run out of memory, but it would be problematic. This is NGC 7332, a galaxy in Pegasus. It's magnitude 11.1. It's 3.18 by 1.1 arc minutes, which means it's a suboblate. The interesting thing about this galaxy is it's a spiral of the lenticular class O, which, as you may recall, ooh, there's a beautiful edge on up there too, as you may recall, is a galaxy that doesn't really have distinct spiral arms, but is more of a disk, like the Sombrero galaxy. So there is our view of NGC 7332, and if we're fortunate, the next galaxy will be that wonderful edge on that's above in the screen, but it's in a low contrast area. Well, I was very fortunate. I had to go quite a ways to get to it. That edge-on galaxy should prove to be NGC 7339 in Pegasus, and I'm going to go and gather the data on that as well. Now, you should look at it and see if you can get a sense, I recommend, of its overall brightness. Look at the core. I'm looking at it, I can see extensions. I'm thinking it's probably somewhere around magnitude 13. I'd like to get a brighter edge on. I don't think 891 is available at this point, which would be a fantastic galaxy to look at, by the way. In fact, NGC 7339, galaxy in Pegasus, is magnitude 12.2, so it's a little brighter than I thought. It's not a pure edge-on. It's at 2.8 by 0.7, so the ratio is about 4 to 1 between the length and the width of the galaxy. It's a spiral with a bar and a lowercase bc, 59 million light years distant, and it's at plus almost 24 degrees in declination. A very sweet galaxy, however. Edge-ons are always very, very exciting to look at. As our edge-on spiral begins to dissolve, we're looking for NGC 7385. You may already be noticing that NGC 7385 is a rather undistinguished galaxy, and I'll tell you why, although they are deserving of tremendous respect. This is a magnitude 12, 1.3 by 1.1 arc-minute sized elliptical galaxy, 353 million light years distant. It's probably about 110 to 110,000 light years in diameter. It's at 11.5 degrees declination. The fact that it's elliptical means that on the Hubble diagram it would be off to the left. There's E's and E3s and E5s and E7s and E9s, and all these basically describe the height to width ratio of the galaxy, so they get to be more saucer-like as you get up to E9. The key is they have converted a tremendous amount of their cold, dark, star-forming matter into stars. They're very bright. They have very little star-forming material left in them. They typically have come about because over time their mass has swelled and they've drawn in things like globular clusters using gravity and smaller dwarf galaxies. And some of them even draw in galaxies of their own size, as will happen with our own galaxy, which is 100,000 light years across, is drawn in a spiral dance of gravitational influence with Messier 31, which is 152,000 light years across. at which time there will be a tremendous burst of star formation, and our galaxy will probably become a lenticular. The joint galaxies will probably become a lenticular at that point, awaiting future evolution in order to become an elliptical, such as NGC 7385. Now watch this. NGC 7385 has a neighbor, NGC 7388. It is exceedingly faint. I'll give you the data on it in a second. Seeing something in the middle of the screen, but that can't be it. NGC 7388 is a galaxy in Pegasus, magnitude 17. It's a 0.2 by 0.2 elliptical galaxy, so it's very evolved. But they can be very small. For instance, Messier 32, a satellite galaxy of the Great Andromeda Galaxy 31, is only some 6,000 or 7,000 light years across. This galaxy is magnitude 17 elliptical. There's no specification as to distance. It's at plus almost 12 degrees in terms of declination. The key to determining its distance would be to find out its redshift value. The most distant redshift I've encountered now is about 1.3%. And that was explained in a previous video where I was talking about the most distant galaxy I have imaged yet, which was one I imaged, I think it was 7427 the other night. So you might want to look at that video. But here we're seeing a 0.2 by 0.2 elliptical galaxy, magnitude 17, and at these settings we should be able to see it. I'm going to make this our Carpe Noctem moment. And I hope that some of these insights will augment just the beauty and the wonder of seeing things in the night sky with an understanding and appreciation of what the heck is really going on out there. Carpe Noctem.